Hello and welcome to Varsity Eco. Today we are going to start continuing from the last class of axioms, assumptions and definitions. Now we are in the area of indifference curves, and first we are going to draw the indifference curve which is convex to the origin, the usual indifference curve, and we will show how based on the axioms we draw it and derive many of its properties, important results. Then we will move to the law of diminishing MRS, and if you have watched the class on cardinal utility, then we will connect it, proving that MRS has no connection whatsoever with MU as far as the diminishing nature is concerned. And then we will go to all possible types of indifference curves, we will draw them, we will discuss the underlying preferences and also their MRS. Okay. So let's start. Okay, so now we are going to derive indifference curve convex to the origin with the help of the axioms and assumptions that we have made in the last class. So diagrammatic derivation of indifference curve for two goods which are imperfect substitutes, because if there is something else then ICs will be different, and right now we are interested in convex to the origin IC. Okay. So our setup was good 1 and good 2. Okay, so two commodity world, two axis, so good 1, good 2. To begin with, let us consider a point, say A. So this is x1 naught, this is x2 naught. Now, to bring in the axioms, let us create 4 different parts on this plane. Now, with respect to A, we know that in this region, both x1 and x2 are strictly more than the given bundle. So that means utility is higher. And in this region, the opposite thing is true. So here utility will fall. We are a little bit undecided when it comes to these two regions. Okay, so let us take the second point here. So let's say this is some B with x11 and x21. Again, for B, we can do the same exercise. Okay. And we will argue same way that in this region utility is definitely increasing and in this region utility is definitely decreasing. So that means if we have to draw an IC, we have to draw it within this box. And completeness tells us that we cannot have any bundle here or any pair of bundle actually within which the consumer is undecided. Alright? Okay, now how can we possibly connect these 2 points? Technically speaking, there are 3 options. So one option is a straight line, one option is something that looks like this, and the other is something that looks like this. And these 3 are equal candidates of being an IC. But we have made convexity assumption which says that this is not going to be not the case, and the straight line one is also not the case. So technically speaking, the convexity assumption, the more is better assumption or local non-satiation assumption, the completeness assumption, all of this together makes this IC, which is convex to the origin, and as we discussing, I think most of you know that straight line is the case of perfect substitute. So in this diagram we have taken imperfect substitutes. Now, based on these axioms, we can line up a lot of results on these ICs, and that is what we are going to do. But before that, apart from indifference curves, we are going to write the definition of indifference map, because as it happens, the consumer does not really end up with only one IC going from A to B. Anyways, so simple, the collection of indifference curves is known as indifference map. Now, as far as the questions are concerned, technically, to write a correct answer, when you are drawing the indifference curve, a specimen indifference curve, you should also, along with this one, okay, in an exam you should draw 2 or 3 more, and not only that, you should also mention the direction in which the utility is increasing. That is very important, and we will show that we can have 2 different diagrams. Shape wise the ICs are same, but direction wise they are quite different. Okay, so in this case the direction will be away from the origin. Okay, so now some results or comments on IC and indifference map. In the earlier section we have drawn a continuous indifference curve, so that means we have also used the assumption of continuity, but I didn't say it properly. Anyways, so now we are on the comments section, or you can treat them as results also. Number 1, by completeness, indifference map, indifference maps do not have empty spaces, because that will mean that you have no idea about the ranking or preference in those of the bundles in that specific region. You can assign the utility of 0, but saying no idea is out of question. So empty spaces, that is, ICs cannot have any gap. When we draw diagram, we generally draw ICs like this, but that is obviously not the reality. Okay. Now, although it cannot allow gaps, but it can be discontinuous. You may think that gap implies discontinuity, nothing like that. The classic example is lexicographic, which is discontinuous definitely, but not empty. Okay. Number 2, since ICs are drawn with respect to specific utility levels, they are also called level curves. Number 3, this is actually a consequence of this one, the first one. So between any 2 IC there exist infinite number of ICs. So we can write it as dense map. In future, I think if you really go to higher mathematics, you'll understand what this word dense here actually stands for. For the time being, this is what it actually means. Okay. Number 4, which we mentioned slightly earlier, ICs are distinguished based on their shapes and utility levels, but indifference maps are distinguished based on the direction in which utility increases. Okay. So obviously, if we have convex to the origin IC and straight line IC, the maps are definitely different. But we can have maps with 2 desirable goods with convex to the origin IC and 2 undesirable goods with again convex to the IC, where in the desirable scenario utility will increase in this direction, and in the undesirable scenario utility will increase towards the origin. So these are definitely different preferences, but they are different only in terms of the map. So whenever you answer any question related to drawing of the indifference curves, okay, it is very important that you also mention the direction in which utility increases. Right? Okay. Now the famous one, the last one, that is 2 ICs cannot intersect. Okay, so we are going to prove this one. Right? So let us draw the diagram. 2 ICs. So let's say U1 and U2. Good 1, good 2. So we're going to choose 1x1 naught, and because there are 2 ICs corresponding to it, we have x2 naught and x21. Let's say B1 and B2. Also, we are going to take this point at which they are intersecting, and let's say this is x1 bar and this one is x2 bar. Okay, so this is our construction. So consider 2 different ICs with utility levels U1 and U2, comma, U1 not equal to U2. Okay. Intersecting at A. Now, as B1 and A are on U equal to U1, we can write that u1 equal to u of x1 naught, x2 naught equal to u of x1 bar, x2 bar. And as B2 and A are on u equal to u2, you can write u2 equal to again u of x1 naught, x21 equal to u of x1 bar, x2 bar. So from these two we can say that by transitivity u of x1 naught, x2 naught equal to u of x1 naught, x21, which then implies u1 equal to u2. And this is a contradiction. Now, why this contradiction is here? Because within this we are violating one axiom. Here let's write assumption. So the assumption of non-satiation is violated as x2 naught is less than x1. Hence, two ICs cannot intersect. Now, from that easy proof, we can also write, as we call it, a corollary. So what is the corollary? That ICs cannot be thick, by which we are saying that it cannot be like a band. All right? Okay. Okay. So now we will move on to the famous component of this chapter, the first famous actually, law of diminishing MRS. But before that, in the next section, we will define MRS, understand it through a diagram, and then we will show, again connecting to cardinal utility theory, that there is no connection between marginal utility and marginal rate of substitution, in the sense that diminishing nature of one neither implied nor implied by the diminishing nature of another. Okay, so now we are at marginal rate of substitution. So first point is the definition. So MRS is the maximum amount of good that a consumer is willing to sacrifice or give up in order to obtain one additional unit of the other good. Okay. And if we write MRS 2, 1, then this means marginal rate of substitution of good 2 by good 1. So good 2 is being substituted. right? Okay. Now the law of diminishing MRS, and it is what the name suggests, right? So the MRS decreases as more of one good is substituted for the other. Okay, so now we are going to clarify the meaning of it with diagram, and we are also going to show in a small way that convexity implies this law. Okay. Before we begin, just remember one thing. MRS talks about, if we go by mathematics, MRS talks about the first order differential, whereas the law talks about the change in MRS, that is the second order differential of the utility function. Because sometimes I have seen people become totally confused between these two. Okay, so let us draw the diagram. Now, in this diagram, one thing is very important to remember, that is that we take the same amount of x1 in consecutive points. So for example, if I take this to be x1 naught and this to be x2 naught, so the same gap will be there approximately, obviously, between x11 and x12. Okay, so now you can realize that the law is actually being followed. So this is this h1, x2 naught, h2, x21, and h3, x22, or to keep balance, h0, h1 and h2. Okay, so our direction of movement is in this direction. That is why we have taken the gaps of consecutive first good as identical, approximately identical. Okay, so this is very clear, right, that this is the gap when I am moving from naught to 1, and this is the gap when I am moving from 1 to 2, and definitely the gap has become smaller. So MRS 2, 1 is decreasing as good 2 is being substituted by good 1. So in your bucket or basket, good 2 is going down and good 1 is growing. Okay. Now, in terms of differentiation, it is very easy to write it down. MRS 2, 1 simply means minus of dx2 dx1. Okay. And this is a very important result in the sense that not only because it connects slope and MRS, that is trivial, but more so because next when we will be proving that there is no connection whatsoever between diminishing MRS and diminishing MU. This is the point where we will start. Okay. So now in a small way, if we want to see this result that convexity implies this law, we can work it out like this. We have said that MRS is diminishing. That means dMRS dx1 is negative. This is what the law states, right? And if we apply this differentiation structure, then this essentially means that dx1 of minus of dx2 dx1 is negative, which means minus of d2x2 dx1 square is negative, and that means d square x2 dx1 square is positive. And mathematically speaking, this is convexity. So that is why convexity implies law of diminishing MRS. That is why Mascarell writes that there is no point of writing both of them together, that we have an IC convex to the origin which follows the law of diminishing MRS, because it is just you are repeating the same thing. Okay, the result is diminishing marginal utility is neither necessary nor sufficient for diminishing MRS, and by extension for convexity of IC. So this means that the famous law of cardinal utility theory is not at all required here. Okay, and this is what basically generates several different cases of IC. Okay. So proof. Consider a utility function u equal to u of x1 comma x2. Okay, which is twice, or rather which has twice continuously differentiable structure. Just to say that the partials exist. Okay. So given an IC u of x1 comma x2 equal to u bar, it basically means that del u del x1 dx1 plus del u del x2 dx2 equal to du bar is 0. Remember, this part, that is the partial differentiations, partial derivatives, this part is an identity. So it doesn't matter what kind of utility function we are working with, okay? As long as it is differentiable, we can write it. So from here, we can write that basically mu1 dx1 plus mu2 dx2 equal to 0. And then if we go to our MRS, dx2 dx1 is equal to minus mu2 by mu1. So that is, minus mu1 by mu2. Sorry. So that means if I just remove the minus sign, it will become MRS. Okay. Alright. Now, the law is about the second order. But before that, the law of diminishing MU implies that mu11 less than 0 and mu22 less than 0. And we have to show that this tells us nothing about the diminishing nature of MRS. Okay. dx2 dx1 is equal to minus mu1 by mu2, and we are interested in d of dx2 dx1, that is d2x2 dx1 square. Obviously we are going to think that, because we are working with imperfect substitute, so mu1 contains some x2 and mu2 contains some form of x1. So that essentially means that if we proceed, let us keep this minus sign here. So mu2 square, then first by x1, so mu11 plus mu12 dx2 dx1 into mu2, then minus okay. mu21 plus mu22 dx2 dx1 to mu1. Right? Minus at the beginning. So now we are going to replace mu11 plus mu12 into, this is minus mu1 by mu2 into mu2, again minus mu21 plus mu22 into, again putting that, minus mu1 by mu2 multiplied by mu1. So minus mu2 squared. Now if we open things up, mu11 into mu2 minus mu12 into mu1 mu2 minus mu21 into mu1 and minus minus plus mu22 into mu1 square by mu2. So that things look nice, we are going to multiply by mu2, both above and below. So it will become mu11 into mu2 square minus, now here we are going to apply our Young's theorem. So we can write 2 into mu12 into mu1 into mu2 plus mu22 into mu1 square divided by mu2 cube. So applying Young's theorem, which states that mu12 is equal to mu21 if we have continuity. Okay. Alright. So now what does this mean? This means that d2x2 dx1 square positive implies mu11 into mu2 square minus 2 mu12 into mu1 into mu2 plus mu22 into mu1 square divided by mu2 cube is negative. Okay. So this is the condition to be satisfied for diminishing MRS. We can add a now here just to complete. Okay, so what we observe here is that if we bring in the law of diminishing MU, then it implies that this one is negative and this one is negative. But it says absolutely nothing about MU12. So depending on the sign of the cross partial, this expression can be negative or can be positive. Then again, if we remove this requirement of law of diminishing MU altogether, that is to say, if we take mu11 and mu22 to be positive, alright, then also we have no idea, because this term again become quite negative with the cross partial actually becoming positive. Okay, so we are going to write just that. So here we have an ambiguity. We talked about necessary and sufficient, so we have to write it to show that it fails in both the parts. All right. Number one, if mu12 less than 0, its value may be so large that even with diminishing MU, the entire expression becomes positive, that is diminishing MRS does not hold. So you can write, hence a diminishing MU is not a sufficient condition. Number 2. So let's go away with this diminishing MU altogether, right? So if MU11 and MU22 both positive, then also we can have MU12 positive and the value of minus 2 MU12 into MU1 into MU2 so negative that law of diminishing MRS holds. And that means diminishing MU is not a necessary condition either. So, if we put them together, we got our result. And the result is that diminishing MU is neither necessary nor sufficient for diminishing MRS. Now this is a big result, because if you have gone through the cardinal Euclidean theory and the derived demand curve thereby, then you know the important role that MU itself plays, because MU becomes the demand and its diminishing nature holds the law of demand also. But here it has no role to play. There is one more thing which is not a part of this result obviously, but just to finish this topic, if MU12 is equal to 0, then what happens? Then we have MU11 into MU2 square plus MU22 into MU1 square as negative, because these two are negative. That means if MU12 is 0, then law of diminishing MU implies law of diminishing MRS, and that is why this separability or independence of Euclid derived out of commodities, this was so vital in cardinal Euclidean theory, because as long as it is there, even in our ordinal Euclidean setup, the diminishing MU implies diminishing MRS. But the moment we make it go away, the moment we allow for implicit imperfect substitutes, the MU loses its importance totally. Okay? So in the next section, we will look at different ICs. we will look at their preferences and the MRSs alongside. Okay.